Hello everyone. Today we're going to be talking about integer exponents. So let's start off with how integer exponents appear. So in this first example, if we take 5 to the exponent 3 over 5 to the exponent 7, this ends up becoming 5 to the exponent 3 minus 7 using our exponent rules. When we divide powers with the same base, we can subtract the exponents. And as you see, we're going to end up with a negative exponent. So thus, the creation of integer exponents. So first, how did it become negative? Well, it became negative because the denominator has 7 factors of 5, where the numerator has 3 factors of 5. So as you can see, I'm expanding the powers. 5 to the exponent 3 in the numerator, so 3 factors of 5, and 5 to the exponent 7 in the denominator, 1, 2, 3, 4, 5, 6, 7 factors of 5 in the denominator. So if we just reduce fractions, 5 divided by 5 becomes 1, 5 divided by 5 becomes 1, 5 divided by 5 becomes 1, and we're left with a value of 1 in the numerator divided by 1 to the exponent 3, which is 1, times 5 to the exponent 4. So you can see where these 4 factors of 5 appear. And where do they exist? In the denominator. If we were not to write this as a fraction and write it as a single power but not in rational form or fraction form, then we would write it as it's written above, 5 to the exponent negative 4. So we can make the connection now that a negative exponent is actually positive when you write it in a denominator in fraction form. So to add to that now, let's do a second example. 7 to the negative 2. Well, how can we write this as a positive exponent? Well, it's going to be 1 over 7. And now we take that negative 2, which was in the numerator, it's a negative 2 because it doesn't exist in the numerator. And we write it as a positive 2 because that's where those 2 factors of 7 exist, in the denominator. So it's positive in the denominator or negative in the numerator. So going from a numerator to a positive denominator. Or if we take a fraction with a power in the denominator, we can write it as a numerator, but it would have to be a negative exponent because we're removing it from the denominator, bringing it up to the numerator where it doesn't exist. So think of that negative 2 as saying it does not exist in the numerator. And furthermore, we can apply this integer exponent idea to bases that are fractions. So if we had 2 over 5 to the exponent negative 2, then 1 over base 2 to the 5 to the positive 2 is how we would write it. And because the base is a fraction, it appears to be more complicated, but treat it as a base and bring that base to the denominator and switch the negative exponent to positive. So that's step 1. Then step 2, what does dividing fractions mean? Well, we take the numerator and we divide by the denominator. And how do we divide fractions? Well, we multiply by the reciprocal. So first let's bring in that exponent 2 by using the power to a power rule. 1 divided by 2 squared over 5 squared. And let's further simplify that. 1 divided by 4 over 25. So now we have a division of fractions where we're going to have to multiply by the reciprocal. I'm just going to go to the next page. And continue example 3 here. 1 divided by 4 over 5 becomes 1 multiplied by the reciprocal, which becomes, oops, I think I made a mistake here. Let me go back. 2 squared is 4, and 5 squared is 25. So, a little slight error there. Let's add that in, 25. And let's go to the next page and also adjust for that. 25, 25. And now let's continue. 1 times 25 over 4 remains 25 over 4. And now let's write this as the original base powers. 25 is actually 5 squared, and 4 is actually 2 squared. And let's remove that power of 2 and write this as 5 over 2 squared. So, big picture, let's put this all together. When you have a base, that's a fraction, and the exponent is negative, you see from the course of all this work that you write 2/5 to the negative 2 as 1 over 2/5 to the positive 2 over here, which ends up becoming a division, which if we deal with the exponent, actually becomes a division of fractions where we multiply it by the reciprocal. And the end result ends up becoming 5 over 2 to the positive 2. So let's equate the start with the end and make some further connections. So we started with 2 over 5 to the negative 2. 2 over 5 to the exponent negative 2. And the result of all that work was 5 over 2 to the positive 2. 5 over 2 to the positive 2. So what is a shortcut that we can use when we have a power with an integer exponent and the base is a fraction and the exponent is negative? Well, you can reciprocate the base. So let's add another example here as I'm explaining it. Let's call it example 4. So we have 2 over 7 to the negative 3. So we have a power. The base is a fraction, is a rational form base, and the exponent is an integer, and it's negative. So when we have this starting point, we can reciprocate the base. So 2 over 7, the reciprocal is 7 over 2. And we could write that negative exponent as a positive. And this is the connection that can be made after reviewing example 3. So if you go back in the video and review example 3, you could see how 2/5 to the negative 2 end up becoming, the end result became 5 over 2 to the positive 2. So the base was reciprocated and the negative exponent was made positive. And example 4 illustrates that as well. That brings us to a close on this video talking about integer exponents. If you're following along from a grade 11 course, specifically 11U functions or MCR3U1, and if you're using the Nelson Functions 11 textbook, you could find this topic on page 217 up to page 223. Thank you and have a great day. You guys are awesome.